All right, let's take a look at a linear function and what is not a linear function. Essentially, a linear function is a function that is a line, in other words, a straight line when it is graphed. So it might look like this or this, you know, any of those would be linear functions on a graph. They would have arrows on the ends, but that doesn't necessarily help you with the equation, just knowing that by itself. Well, what creates the equation that creates a line or a linear graph is when you have y equals, and you've probably seen this form. This is the slope-intercept form of linear equation. But the key to me to this is that you have x to the first power, which we don't ever write to the first power. We just say x, right? So it might look like y equals 2x plus 3, or y equals negative x over 2 minus 7, or something like that. I mean, it can look very different in various ways, but notice that each time you have an x, and x is to the first power. It's just an x. So if you need one that is not linear, then I would say, you know, not linear means that x is raised to a different power, such as x squared. That is not linear. That is a quadratic function. Quadratic function. And so what happens in that is that when you graph it, it will be a U shape. Pretend that that was nice and smooth, but yeah, a little U shape is what that graph would look like. So that would be a quadratic function, not linear. Something else that's not linear would be a cubic. So it might be 2x cubed. That has sort of an S-shaped function, we call it. So generally, this is not this equation, but generally, you know, you would see something like this is a cubic function, C-U-B-I-C. And then that is raised anytime x is raised to the third power. That's cubic. Those are probably the most common. So the quadratic could even be like y equals 2x squared minus 4 or something like that. Like those are quadratic functions. And again, the key is that the x is raised to a different power than 1. All right, I hope that helps.